Now we're in chapter 1.2, and we're going to start talking about functions, what makes a function, what's not a function, domain, range. Um, we have been talking about this since at least Algebra 1, but it's all very important, kind of like the backbone for the kind of stuff we're going to be doing throughout the year. So since we talk about functions all year, it's important to have kind of the basics down. We'll be asked a lot on our AP exam about different characteristics of functions. So a relation is any two variables that are somehow related to each other. It could be by any rule of correspondence. That just means there could be a graph, there could be a table, there could be an equation. We're just relating two variables. So if two variables have some sort of relationship, it is called a relation. You can have domain and range of a relation and of a function. So domain would just be the set of x values in the relation. Oops. Now for our AP test, instead of always saying x, because x doesn't have to be the variable, really they're going to mostly be referring to inputs. The inputs of the relation, when you put something in, what do you get out, that kind of thing. Inputs, those are also known as the independent variables. And then the range is we're used to thinking the set of y values in the relation. But again, because it's not always x and y, like we saw in previous homeworks, it could be t and s or t and d, something like that. They will often just refer to the range as the outputs, sometimes the dependent variable. And instead of just looking at general relations, although sometimes we do, we are mostly focused on functions. So a function is a specific type of relation. It's a relation in which every item in the domain is mapped to exactly one item in the range. And if that's the case, then you have a function. So it can't be that one of the x values in the domain doesn't get mapped to a y value. It can't be that an x value has two different y values or three or whatever. It has to be exactly one. Common function notation is this. You would read this as f of x. The long way to say that is we're using f for the function name, but y is a function of x. Or d is a function of t, or s is sales is a function of time, whatever. Guidelines for function relating set A, which are going to be our inputs, to set B, which are the outputs. So input for A, output is going to be set B. So each element in set A must be matched with an element in set B. So like I said, you can't leave an input out. Some of the elements in set B may not be matched with any element in set. Some of the elements in set B may not be matched with any of the elements in set A. Sorry, that's a typo. Two or more elements in set A may be matched with the same value in set B. Okay, so that's like x's are 1, 2, 3, and 4, and they all have a y value of b, or they all have a y value of 5. That's okay, because they're all just matched to exactly one number. Each element in A cannot be matched with two different, or more than one really, elements in set B. So don't overthink this. You're not going to have to write these out for an AP test. It's just, does it meet the definition? Does this relation meet the definition of a function or not? Function notation again, for the most part, input is x, output is f of x. Again, you could make this t, f of t. It could be w, g of w, whatever. Evaluating, if you're told to evaluate a function, this is read f of c. Evaluate f of c means plug c into the equation for f of x and simplify. C is the input, f of c, the answer you get, is the output. Always simplify. The rule for our AP test is if you can simplify without the aid of a calculator, you must do it. So they won't give you credit if you leave your answer as 2/4. They would knock that off and say that's not fully simplified. So reduce everything, simplify what you can. Determine whether each relation represents y as a function, another type of x. Y as a function of x just means x is the input, y is the output. Does it follow the one output for every input rule? Okay, so right here I'm seeing that we have an input of 2 listed out twice in the table, and it's mapped to 2 different output values. So this is not a function. If we're looking at a graph instead of a table of values, this is just graphically kind of a visual, not of the same table, but you could look at it the same way. As long as you don't see any points that have points directly below or above them, that means that every x value has just one y value. So one y value for -1, 1 for 0, 1 for 1, 1 for 2. So yes, this is a function. Y is a function of x. If you're given an equation, then you need to solve the equation for y. Now, you might not always have to solve for y, but like you'll get into a pattern where you figure out the rules, but solve for y. And then you're kind of checking, like, as long as I don't have a plus or minus, or as long as if I sketch this graph, as long as I don't see any x values that have multiple y values, then this should represent a function. And we'll talk about some patterns that we see. So here, to solve for y, I just would subtract x squared. And you can generate a table of points. Like, you just start thinking about it. Let's just make an xy table. I'm going to pick some negatives and some positives. If I plug in -2, y is 1 minus -2 squared is 4. 1 minus 4 is -3. So when I plug in -2, I only get one answer of -3. When I plug in -1, square it, 1 minus 1 is 0. I only get one answer, it's 0. When I plug in 0, I get one answer of 1. So you can see, you might not have to finish your table, but I'm pretty convinced that every number I plug in, I'm just going to get one output for that input. Now, some of my outputs might match. When I plug in +1, I get 0 again, but that's okay. You're allowed to have different inputs get the same output. It's just that one can't come up as like plus or minus 3 or something like that. So this is a function. You could also think about this graph. We haven't talked about transformations yet, but you've done so much in Algebra 2. You might remember that this graph looks like that. And I know we haven't talked about vertical line test yet, but you might remember that that vertical line test shows you one input and goes to one output. Now for this one, if I need to solve for y, first I get y squared by itself. And then when you introduce a square root to both sides of an equation, you have to remember this plus or minus. Y squared is plus or minus the square root, I'm sorry, y is equal to plus or minus the square root of 1 minus x. Because excuse me, y squared, you can plug in a positive or a negative for y, and y squared is going to come out to be the same value. So when you think about generating a table for this, now I've got to put numbers in I can actually use, like 0, -1, -2. The y values generate plus or minus the square root of 1, or plus or minus 1. When I plug in 0, I get 2 different outputs, and it doesn't matter what input I get in there, I get plus or minus. For every single x value, there's a plus or minus y value. Because of the plus or minus, y is not a function of x. Think about this rule then. The only way you're going to get a plus or minus is if y has an even exponent. So without really having to prove it, without really having to prove it, I can just say, oh, if y has an even exponent on it, then I'm not going to have a function. Because if I were to solve for y, I would get a plus or minus. In example C, y was to the first power, which is an odd exponent. If y were to the third power, another odd exponent, and I cube root both sides, odd roots do not have the plus or minus because you can odd root a negative. There's only one answer. Negative 2 to the third is only negative 8. 2 to the third is only positive 8. You don't get that, like, if you put in plus or minus, they don't come out to the same number. So odd exponent on y, you're going to have a function if there are no other weird things happening. Other weird things happening would just be like, I don't know, do you have a square root or something? So this is something to investigate. So here again, you can generate a table. This square root is already in the problem, so there's no plus or minus. Plus or minus is only if you have y to an even exponent and you root both sides, you get the plus or minus. So here, if I plug in 0 for x, I don't get plus or minus square root of 2, I just get square root of 2. If I plug in negative 1 for x, I get square root of 1. No plus or minus. So a square root function is a function. We'll talk about graphing in the next couple of days, but this one, remember, is moved left and looks like that. Passes the vertical line test. Okay, evaluating functions. So this is more math-minded. We're plugging stuff in now. So remember, evaluate means to plug in the number. We're given two different functions. One is named f, one is named g. We want to find f of 2 plus g of 1. So all that means is plug 2 into f. 1 minus 2 squared. I don't know why I put parentheses around that. 1 minus 2 squared. And then add to that g of 1, 2 over 1 minus 4. Okay, so f of 2 is 1 minus 4, negative 3. And we're adding to that 2 over negative 3, or we're subtracting 2/3. I should probably put equal signs here. F of 2 plus g of 1 equals this, which equals this, which equals, yeah, we could just say negative 3 and 2/3. But mixed numbers, not that they're wrong, I just, mathematicians, it's easier to work with fractions if they're in their improper form. And I want you to get in the habit of getting common denominators and getting comfortable with that. So yes, this is negative 3 and 2/3. Or you could say negative 3 is negative 9/3 minus 2/3. That's negative 11/3. So I'm not going to count it wrong if you say negative 3 and 2/3, but I only use mixed numbers if I'm trying to plot that point so I can more accurately plot it between negative 3 and negative 4, for example. G of 4. So G of 4 is simply plug in 4. But here we run into a problem. 2 divided by 0. 2 divided by 0 is undefined. We cannot divide by 0. Think of it this way. There are a few proofs for why this doesn't work, but I always think of it this way. When I say take 10 and divide it by 2, that means divide 10 into 2 equal groups, right? Take 10 divided by 1. Take 10 and divide it into 1 equal group. Well, how do you take 10 and divide it into 0 equal groups? You're basically saying, like, make this thing disappear, right? And so dividing by 0 means undefined. It's not actually a thing. We will get to rational functions down the road. 4, x equals 4, is not in the domain of g of x because there's a vertical asymptote there. Okay, last one of these. F of negative 3 divided by g of negative 4. So f of negative 3 is going to be 1 minus, and then we're squaring negative 3. So that becomes positive 9, but it's still 1 minus. I get this mistake a lot, actually. I want to talk about this. You can't make minus negative plus before you square because you're multiplying before you use an exponent, and that goes against order of operations. So we make it 1 minus 9. So that's going to be negative 8. And then negative 4 2 over negative 4 minus 4. So the numerator is negative 8. The denominator is 2 over negative 8. So let's make that negative 1/4. We must simplify. It looks terrible to have a complex fraction, but also we want to get our AP credit and just have our math number sense facts down. So 8, negative 8 divided by negative 1/4. First of all, the negatives can divide out to positive 1. This becomes 8 times 4 over 1. So 32 is our final answer. And the last thing we're going to talk about today are piecewise defined functions. So a function can be defined by more than just one equation. It can have 2 or more equations on a specified domain. So if it's going to be a function, the domains can't overlap, meaning the pieces, if you graph the thing, won't have any parts where they fail the vertical line test. To evaluate, to plug in numbers into a piecewise defined function, use the domain to determine which equation to use. So you're not plugging into, so don't plug into multiple equations. If I say find f of 2, you should only have one answer. It's not that it's this, this, or this. So here's f of x. It has 3 pieces to it. For x values less than 11, we use this 2x plus 3. When x equals 11, we use the y value 5. And when x is greater than 11, we use this line. So find f of negative 2. Negative 2 falls into the x less than 11 category. So plug into 2 times x plus 3, and just do the math. Negative 4 plus 3, negative 1. F of 20, 20 is an x value that's greater than 11. So we're plugging into the bottom, 3/4 times 20 minus 2. Please get into the habit of dividing before you multiply in terms of fractions. Like instead of saying 3 times 20 is 60 and dividing by 4, you're giving yourself bigger numbers to work with. Reduce 20 over 4 first. You can divide 4 by 4. You can divide 20 by 4. And then you've got 3 times 5 is 15. 15 minus 2 is 13. And then f of 11, like I said, if x equals 11, there's no calculation needed for this function. The answer is 5. So sometimes that's confusing to people. Sometimes you want to do 5 times 11 or something, but it's showing you the answer. Okay, here's g of x. It has 2 pieces to it. For x values greater than or equal to 3/2, we're on the top. For x values less than 3/2, we're on the bottom. So when x equals 3/2, g of 3 over 2, we're on the top piece, greater than or equal to. So plugging into this, square root of 2 times 3 over 2 minus 3. Again, this 2 out here, common mistake I get, even in pre-calc, people want to do 2 times 3 over 2 times 2, but this is 2 over 1 times 3 over 2. So again, your 2's cancel, and you just get square root of 3 minus 3. And that's square root of 0. All these silly little details, they seem like kind of silly questions, but again, I get them a lot, or we start second guessing ourselves. So there are no silly questions, just the ones that you don't ask. Square root of 0 is equal to 0. Remember, a square root means what times itself gives me this number. 0 times 0 is 0. G of negative 4. Negative 4 is a number that is less than 3/2. So we're plugging into negative x squared. Again, common mistake. I just talked about this in the previous problem. You can't change the minus negative to a positive. You've got to square negative 4 first, and then multiply by this negative 1. The answer is negative 16. Basically, negative x squared has to come out negative no matter what, unless you're plugging in 0. G of 6. 6 is greater than 3 over 2, so we're going to use the top piece. 2 times 6 minus 3, the square root of that. 12 minus 3 is 9. The answer is just 3. It's not plus or minus 3 because the square root is built into the problem. So that's another, I made this problem because it has like all the classic mistakes that I see in it. Forgetting to simplify square root to 0, that'll ding us on our AP test. Accidentally making negative x squared positive, and when you get a square root, making it plus or minus, but the square root was in the original problem. So it's only plus or minus 3 if I say, when does x squared equal 9? The answer is plus or minus 3. What is the square root of 9? 3. Okay, so lots of little details. The math is not hard. The little simplifying details can get confusing.